Bismillahirrahmanirrahim. Greetings. Quite many college students taking freshman and sophomore mathematics courses have difficulties with the concept of absolute value and its application. Now, in this video lecture and two or three more to follow, I intend to dive deeply into the subject and discuss it in more detail. Now, in this video lecture, I'm going to first introduce the geometrical interpretation of absolute value, and that can motivate and lead us to the analytical definition. And once that one established, we will apply it for solving some problems. So that will be the contents of this video lecture. So let's get started, shall we? Now, geometrically, by the way, I do zoom, that I don't have somebody behind the camera to zoom in and out for me, unfortunately. After I made some talking, I will go and zoom it so that the written letter, words will be more visible to you. And I will try also to stay out of your way. Okay, now, going back to the subject. Now, geometrically, absolute value of a number means how far that number is located on the number line away from the origin. So the word how far means distance. So distance is involved. And distance is always represented by a non-negative numbers. All right? So in that regard, 3 and negative 3 are located to different parts of the number line. They are in a sense mirror image of each other with respect to the origin, but their absolute value on the line, their distance they are away from origin is same. A good analogy will be a semi-truck driver. Let's say he charged $1 per mile, and it doesn't matter if he goes east or if he goes west. If he goes, for example, 100 miles to the east, he collects the same amount of money if he goes 100 miles to the west. So that is really the geometrical interpretation of absolute value. Now, before I start, that can also motivate us, in fact, for the analytical definition that I'm going to come soon. But before I go to the analytical definition, let me ask you a question that is related in reality to the definition of absolute value. Now, the question will be, what kind of number is negative x? The appearance of negative x, minus x, to the beginner students, especially, they consider that as to be a negative number. So an intelligent answer to this question will be, I don't know. Tell me what value you are assigning for x, or what value x has been assigned to, or what value x is assuming, then I can tell you what is negative x. That's legitimate and genuine and a smart answer. But this is not the way a person who has maturity in mathematics will answer it. So how would he or she answer it? He doesn't ask this question, even though it is legitimate to ask it. He says he or she takes the cases under consideration, and based on those cases, he answered the question. So a number can be either positive, 0, or negative. There are 3 possibilities of a real number. So now he's answering the question. He said, if x is assuming, or you are giving me a negative number, like negative 3, then negative x will be positive number, because it's negative x. Negative 3 is what? Is positive 3. if the value that you're assigning to x is 0, that is trivial. And if the value that you're assigning to x is positive, then what happened? That negative makes it negative. So if x is 3, the negative makes it negative 3. So that is the answer that a person with some maturity in mathematics will give the answer. Okay, then, looks like we have enough background. Let's start with the analytical definition of absolute value will be. Now, this is, by the way, I don't think I should. This is for you if you want to take a note. Well, by the way, I forgot to zoom that one. Let me zoom it if I may. I believe that is more kind of visible to you. Now you can write the notes if you want, that geometrical representation that I just mentioned a few minutes ago. Okay. Okay, Rabbit. Now let's go to analytical definition of what? Analytical definition of absolute value. Now, is hopefully visible and readable. Also, you have access to magnifying, zoom it using your computer, so I hope you don't have any problem to read that one if you wish to write the notes. Now here, this is the analytical definition. The analytical definition of absolute value, as I have written, absolute value of x is x if x what is a positive number. Absolute value of x is 0 if x is 0, trivial. Absolute value of x is negative x is if x is a negative number. Now that may turn you down, huh? Now, if you have difficulty, because you know in mathematics the definitions are given in condensed form in every textbook. So it is your responsibility in reality to paraphrase it, to expand it to your full comprehension. So let's go and paraphrase this one in a sense, expand it so that we can comprehend it much better. We can say it this way: if whatever is inside the absolute value gel, let's call it, the two parallel line segment, whatever is inside the absolute value gel, if that whatever is a positive, then leave him alone. So if x is positive, absolute value of that is this. So absolute value of 3 is 3. You don't have to keep 3 inside the gel of absolute value because it's a positive number. So, but why do we keep x in the gel of absolute value? Because we don't know its value. We are assigning value to that. So we are taking our possibilities. So if x is a positive number, then leave him alone. X is 0, trivial, and if the number that is in the gel of absolute value is a negative, then what do you do to make it positive? Multiply by negative. In other words, what is inside the gel of absolute value is not of our concern about the sign. Can be positive, can be 0, can be negative. But we have to make sure that the outcome is definitely non-negative, which means 0 is positive. So the outcome of an absolute value cannot be negative. But inside the gel of absolute value, whatever it is, could be a negative number. So we take cases under consideration. So hopefully you are clear with the definition. Now you can pause, think, reflect, contemplate. Don't write any note, try to comprehend it perfectly in your mind and in your heart. And then if you couldn't, go back again and listen one more time, and you can do it for 10 times if you wish, so that you fully comprehend before you go further. Okay, now let's go and see some interpretation of this of this what? Of this analytical definition of absolute value. So how would you interpret x minus 3? Let's interpret this one together. What is inside the gel of absolute value can be positive, can be negative, can be 0. I already mentioned, I'm repeating. The outcome of that must be positive. So any number you assign for x which is 3 or bigger, will dominate the sign of this one, the outcome will be positive. You follow? Any number that you assign here to the left of 3, if you give it 3, you get 0, huh? You give to the left of 3, the number inside the what? Inside the gel of absolute value will be negative. So if you want to know the output of that, the outcome, you have to multiply it by negative 1. For instance, if x is negative 10 and negative 3 become negative 13. So if you want to, negative 13, there is nothing wrong. It can be in the gel of absolute value. We have no problem with that. But if you are going to take it out for any possible use, you have to multiply it by negative 1 and make it positive. So negative absolute value of negative 13 is not 13. Don't say it that way. If somebody asks what is absolute value of negative 13, says negative 13. Negative 13. Do you follow me? So that you know you are applying what? The analytical definition of absolute value. Okay then, so far so good. Let's see what happens to this definition and how we can apply the definition of absolute value for this. So we have already interpreted that one. This will become a little bit kind of extra. All right, Rabbit. Let me put this one here, this one here, so that I know. Okay. Applying the definition of absolute value. He says that absolute value of x is x if x is what? If x is a non-negative number, positive. Let's take it as a positive, if x is positive. Now here, that x that we mentioned in absolute value is x plus 3. You see? It's bracket. You know, inside the gel of absolute value can be a big algebraic expression. Could be x cubed plus 7, x squared plus 13x plus 7. Could be something large. It doesn't matter what is inside. If it is positive, then what? Don't keep him in the gel of absolute value. Leave him alone and consider that. So if this is positive, this is your x. You know, x minus 3 stands for the x of the analytical definition of absolute value. So if x minus 3 is positive, then what? Then you go proceed that. In that case, if x minus 3 is positive, means if x is greater than 3. If x is 3 is trivial. If x minus 3 is a negative number, nothing wrong, it could be negative inside the gel of absolute value. But if it comes out, you must multiply it by negative to make it positive, according to the analytical definition of what? Of absolute value. So look what happens. If it is negative, this is your x. This is the same x that we applied in the definition. Our x here is x minus 3. Alright? So if x minus 3 is a negative number, you see, if it is negative number, then you have to multiply it by negative to make it positive. So then become 3 minus x. You are taking 3 consideration. So this is the interpretation of one application of what kind of problem. Now let's see how we can apply it for solving possibly some related problems. Now we start with ease before we make it a little bit more kind of complicated, huh? Okay, solve this one. Number 1, always try not to be mechanical. Don't follow recipes. Try always think, reflect, contemplate, before you start. The best way to do it here, first to do it by inspection. As I said, don't be mechanical. Now by inspection, look at that and see what kind of number you can put for x so that the outcome will be 5. So if I put 1, no, 1 minus 3 is minus 2 is not 5. 2, no, 3 is 0, and so on and so forth. So you know if you put 8 minus 3 is 5, absolute value of 5 is 5, is that right? So it's correct. Now, what about if you put other number, like said negative 2? If you put negative 2 and negative 3 is negative 5. Nothing wrong with negative 5 as long as it is in the jail of absolute value. But we want the output of it. We want to know what. So what happens? We multiply it by negative. So what happens? Negative times negative, 1 times negative 2 becomes what? Negative 5 becomes positive 5, which is satisfies this equation. You follow that? And then you can put it in set notation. In this case, there are only 2 answers, 8 and what? And negative 2. So the set of solution for this is 8 and negative 2 because it's equality. Now, look, well, I have put this one, well, what I just said, I have put it in writing. Let me hold it up for a few seconds if you wish to write a note of that, huh? What I just said is the writing of that, huh? All right? That's good. All right, Rabbit. All right, now let's see how we can solve a problem like that. Same thing, x minus 3, but less than 5 rather than equal to 5. How do we solve? Again, I repeat, advising you, do not be mechanical. Always think and reflect, contemplate before you start that. Look at it, what you have to do. All right, here we know the outcome must be what? Must be non-negative. By inspection, we know that if we take any number bigger than 8, let's say for example 10, 10 minus 3 is what? It's 7. 7 is not less than 5. Is that right? So you know any number to the right of 8, bigger than 8 will not work. Similarly, if you take any number less than 2, less than negative 3, excuse me, I said less than 2, less than negative 2, less than negative 3. If you put negative 3 for x, you get negative 6. But absolute value of negative 6 is negative 6, which is positive 6, and positive 6 is not less than 5. So any number bigger than 8 and less than negative, but negative 2 will not work. So whatever in between, every number in between will work. So the solution will be the set, in set roster notation, the set of all values of x, such that those values are between what? Between 8 and negative 2. Are you with me? Great. All right. Now let's look for some other examples. Now, oh, I have something for you. This is good to say, to test yourself, if you have really comprehended the idea. Solve this one for me. Before it was less than 5, now it's greater than or equal to 5. First do it by inspection so that you have the idea. If you want geometrically, you can put it on the number line, if that can help you. If you're a beginner, why not? I do encourage you to do that. And after that, apply what? The definition of absolute value. X minus 3, this bracket represents the x in the analytical definition of absolute value. All right? All right, now let's go to next. Next is, did I, x minus 3. I think this one I have already mentioned. I'll go over one more time. just for the sake of it, absolute value of x minus 3, we want to solve it. Algebraically we want to solve it. Before we did it by inspection, huh? Let's do it algebraically. If this whatever is inside the absolute value j, if it is a positive, leave him alone. Here it is, I left it alone. Leave him alone and solve it. So x minus 3 will be less than 5, because whatever was inside the absolute value was a what? Was a non-negative number. So we left him alone, and now we have to solve algebraically what will be the, let me cover this part so that your concentration goes on that one. Now we have to solve x minus 3 less than 5. You know, very grade school solution, you add to both sides plus 3 and you end up with x, the values that x can assume is less than 8. The values that x can be assumed is less than x. Not so fast. He says everything less than x we put here is equal to 5. We already inspected and we found out that is not the case. It says anything less than 8. Okay, I give negative 10. If I put negative 10 here, I get negative 13. And negative 13, absolute value of negative 13 is negative 13, which is positive 13. And positive 13 is not less than, but less than 5. So that means has further continue. We have to continue further and see what we can come the lower bound of it. In this case, this is kind of upper bound. In a sense, in true sense, is the least upper bound of it. Okay, now we go to the next step of possibility, and that is this represents your x in the definition of absolute value. Of keep repeating that because that is the cause of confusion for most students. So if this is a negative number, then negative of that makes it positive. Is that right? Look at that. I multiply by negative. I'm not doing algebraically. So when you multiply both sides by negative, negative of that is positive. When you multiply both sides by negative, you get what? You get x minus 3 is greater than negative 8. Here, I wrote that negative there, but I forgot to put it here. So let me put it here also. Negative, that's correct. So negative of that is less than 5. Excuse me, no, I didn't do it. Forget that one. Okay, now I multiply both sides by this negative of that. It is correct. Negative of that is less than 5. I don't know what was wrong with me. Now, when you multiply both sides by negative, you get x minus 3 is greater than negative 5. And then again, algebraic manipulation, add to both sides positive 3, you get x is greater than what? Negative 2. Fantastic. That's exactly what we got by inspection. So I put the solution set for you in case if you like to take a notes. Again, my advice to you is what? Pause, think, reflect, contemplate before you go further. Unfortunately, with the technology of computer, you can do such a thing. You cannot do that in a live class. So there is a lot of advantage for that. So this is the same problem, but I put it in a solution. I put in the set raster notation, the solution of that. Okay, now I have a question for you to see if you can answer it. The question is, how do we solve geometrically, by inspection, let's say geometrically and analytically. How do we solve this problem? Let me cover it so that we don't go to the next. How do you solve this one? So if you are mechanical, if you are used to mechanical approach, unfortunately you will be wasting your time before you find out that you were wrong. So why is it wrong? Because we just said that. We went to geometrical interpretation, we went to analytical interpretation. We said what? We said whatever is inside the gel of absolute value can be positive, negative, or zero, but the outcome must be positive. Now here it says less than negative 5. cannot be less than 0. How can it be less than -5? The outcome of that cannot be negative number. But he says the outcome of that is less than -5. So what is your answer? He says, hey man, you're playing joke with me. There is no solution for that. So in another word, in a set notation, you say it's an empty set. So this has no solution. You follow me? All right, now how do we solve this one now? How do we solve this one? X squared plus 1 equal to 5. Now what is inside the gel of absolute value, 100% in this case is positive. Because if you give for x negative, x squared will be positive. If you give it positive, x squared will be positive. Positive plus 1 is positive. So what do? This one we say, this is positive. We take it out of gel of absolute value for all x and we proceed to solve it. How do we solve it? X squared, we end up with to be x squared equals to 4, and that is what another difficulty of the absolute value comes from. And many students have difficulty with a square root of x squared. When you give it to them, it says equal to x. A square root of x squared is not equal to x. It's equal to the absolute value of x, and that will be the subject of that we go over for the next video lecture. So I hope that this was beneficial to you. Again, I repeat my advice to you, always try not to be mechanical, do not follow recipes, always think, reflect, contemplate, and try to improve your critical thinking so that you can succeed in any other branches of science, engineering, and you name it, technology. Because critical thinking is very important and mathematics build that for you. Okay then, I thank you for watching. Have a very nice, pleasant day, and please stay safe. And soon I will be uploading the second lecture, which is a square root of x squared is not equal to x. Alright then, thank you for watching again for the second time, and please stay safe. So long.